All right, lesson 155. I'm making this lesson on May 1st, first day of May. Very exciting. I love the month of May. It seems to be the month where things really turn around with the weather. For me, it's the beginning of summer. Normally Memorial Day is my favorite day of the year, but I don't know how it's going to go this year. But I am pretty excited. Hopefully our family will be doing a family vacation on June 1st. We rented a house over by Lake Michigan for my whole family to get together, all my children and us. So pretty excited about that. Hopefully that all works out. So today we're doing lines of latitude. Lines of longitude we've already talked about. Remember, they're the long lines. They're these right here. And remember, we had the prime meridian, which goes through Greenwich, England. It's 0 degrees. And then perfectly halfway through at 180 degrees, we had the international date line. I think that was where it was. Yeah, the international date line. So there's a total of 360 degrees of these lines of longitude, and they determined time, hours, and the days on our globe. Keep things consistent. Today we're doing lines of latitude. They're the lines that go this way, and I'm having so much fun tracing over this. All right, these are the lines of latitude. The one in the middle you already know. You've learned from history and geography. That's the equator. And then we've got the Tropic of Capricorn, the Tropic of Cancer. We got Arctic Circle, Antarctic Circle. We've learned all those. But latitude, they are degrees either north or south of the equator. When reading or writing degrees of latitude north or south, they must show the direction from the equator. So you don't just put like 52 degrees, you would put 52 degrees north. So it's 52 degrees north of the equator. All right. Let's see here. Let's see. Let me look up top. Let's read number 4. Parallels of latitude run west to east, but measure distances north or south. The length of parallels vary, but the distance between each degree of latitude is fairly consistent. The distance between each degree latitude is approximately 68.7 miles near the equator and 69.4 miles near the pole. So they're just saying like the distance between the lines of latitude closer to the equator are about 68.7 miles apart. Once they get up here near the poles, they get to be 69.4 miles apart. And this is, so they use this measure right here. Use the approximate distance of 69 miles between each. And what they've done is they've just averaged out those two. All right? All right, let's fill in the blanks at the bottom. Blank is the distance east or west measured, All right, blank is the distance east or west measured from the prime meridian. And these are the lines of longitude. Okay? The prime meridian passes through, did I spell Greenwich right? No, it's green. You actually spell it Greenwich. Sorry. 2 E's. Can you see my other E? Blank is the distance north or south. North or south. So these are these lines this way. So latitude. Okay. Latitude degrees are about 94 miles. 64. 9 miles apart. The equator is at 0 degrees latitude. The international date line is, remember, it's the halfway point, 180 degrees latitude. The prime meridian is 0 degrees. Oh, they already have the degree, so I don't need to write that. North of the equator is called the northern hemisphere. South of the equator is called the southern hemisphere. The Earth has how many time zones? Well, there's one for each hour of the day. Find the approximate miles from the equator. Let's just do 2 of these. So remember, it's 69. We're going to average 69 miles between each line. So for 25 degrees, we're just going to do that times 69. We'll do 1. Good multiplication practice, right? This is an 8, by the way, that I'm not going to recognize when I get to the bottom. 1,725 miles. We'll do one more. 8 times 69. (48) plus 7 would be 55. And that would be miles. All right, let's go to the back. All right, going back to lines of longitude. This is review from the other day. So remember, going this way, we're going back an hour. This way, we're going ahead an hour. So if it's 6 a.m. Pacific time, it would be 5 a.m. Alaskan and 4 a.m. Hawaiian. 7 a.m. Mountain, 8 a.m. Central, and 9 a.m. here. If it's midnight in Hawaii, it would be 1 a.m. in Alaska, 2 a.m. in California, 3 a.m. where my daughter lives, 4 a.m. in Chicago, and 5 a.m. here. If it's noon Mountain Time, it'll be 11 a.m. or in California, 10 a.m. in Alaska, and 9 a.m. in Hawaii. And then it would be 1 p.m. in Chicago and 2 p.m. here. Dominic's home is in New York City, but he flew to Los Angeles to visit his grandparents. So New York City is Eastern time, and he's gone all the way to California to visit his grandparents. He was homesick one night and decided to telephone his parents at 9 p.m. before going to bed. Dominic was surprised to find his parents were already asleep. What time is it in New York City when he called? So he's calling at 9 p.m. Okay, he's calling at 9 p.m. when he's in California. So I'm going to put the 9 p.m. up here. Okay? So don't forget that his parents, making 3 jumps, are 3 hours ahead of him. So that's 3 hours ahead of 9 p.m. Well, that would be actually 12, and we call that a.m. Called in the middle of the night. People do that all the time. My friend's daughter moved out to California for a couple of years. In fact, she just came home a week ago, and they had that issue all the time. New Orleans is located 30 degrees north of latitude. How many miles is New Orleans from the equator? So you're just going to do 69 times 30. Let's just do it times 3 and add the 0, and we're done. $2,070 miles. All right. Don't forget my comma. Philadelphia is located on the 40 degree north latitude. How many miles is New Orleans latitude from Philadelphia's latitude? How many miles? Okay, so I got to figure the miles first. So we got to do 69 times the 4. We'll add the 0 in when we're done. 24, 27. So that's the distance. Let's subtract, find the difference, and hopefully I'm right. I get 690-mile difference. So first, what I did, if I went too fast, is I figured out the miles that Philadelphia is from the equator. I did 69 times the 4, because 69 is our rounded number we're going to use. I got 2,760. Subtracted that from the miles that New Orleans is from the equator, and we got a 690-degree difference. Okay? Quito in South America is located on the 0-degree latitude. How far is it from the equator? Well, it is on the equator, so 0 miles. Mumbai, India, is located on the 20-degree north latitude. How many miles is it from the equator? So let's just do 69 times the 2 and add in the 0. It is 1,380 miles from the equator. Okay? All right, these are old. You should know these by now, and I can't do them with you anyway. Let's look at 6 3/4%, just so I want everybody to be done making mistakes with that. That is 6.75%, right? And then you move the decimal over twice, 0.0675 times that. Let me just show you a little trick there. Whoops. Ignore these and ignore this, and let's put them in when we're done. So we can do 675 times, we can just do times 675 again, which is still big enough, right? We'll add the zeros and we'll put the decimal in when we're done. See if I get it right. 5, 49, 51, 35, add a 0, 5, 3, 49 and 3, 52, hopefully I don't mess this up, 42, 47, and then 2 zeros, and 30, and a 3, 42, 45, this is a 4, 36, 40, 5, 6, 7, 15, 5, and 4. So I'm going to write that over here. Let's add in the 2 zeros. Let's put a 0 here, just because to keep it consistent. And we have 1, 2, 3, 4 numbers after the 0. 1, 2, 3, 4. This one isn't necessary. So I get, and I don't even know if I'm right. I'm going to spit nails if I'm not when I look at the answer. I'm getting that because we don't need these zeros either. All right, let's see what I get. I'm super close. I got one number wrong. Oh, that's because I copied that 5 wrong. Oh, that is a 5. I was thinking it was a 3. That's a 5. Okay. So, oh no, that 7's wrong. I did something wrong in my math. 3 and 2 I should have. This is a 3. I messed up right here. So this should be a 5. So this should be a 6. This should be a 6. Oh my gosh. I was close. But anyway, I got the place value totally right. So let me show you that, because that can just so save you time. So let me go through that one more time with you, in case you're like, your eyes fell out of your head. So first of all, I change this to a decimal, right? Well, I'm not changing it to a decimal. I'm making the 3/4 a decimal, because now I move it over twice. So I have 0.0675 to multiply by 67,500. I want to make, so I could do this. I could do that. But man, that's so big. So let's make it smaller. Let's not do these and not do this. We'll save them for later, okay? You gotta just remember you did it. So I did the 6, 7, 5 times 6, 7, 5. I'm not even worrying about the decimals. We'll do that later. And I multiplied. All right? So let me do it real quick again. See if I can get it right. 5, 3, 49, 52, 47, 30, 42, 45. I did something wrong. 2 zeros. I totally did that wrong. Whoops. It's not going to let me erase. There we go. So I have 2 zeros, then 30, and then 45, and then 40. 12, 6, 15. All right, now I think that number's right. Okay, at this point, I can put in these 2 zeros here that I left off right here. I can put this 0 that I left off there. Now I had 4 numbers after the decimal, so I have 4 numbers after the decimal here, so you can see why it was important to put these 2 zeros at the end before I put the decimal in. Now I find out that these 2 I don't need in the final answer. I don't need this in the final answer. So I have 4, 5, 5, 6.25. Okay? All right, I don't know if that helps at all. Look at this on D. 7,326 divided by 100. Well, remember, I know the 5th graders are just doing this, so I know you did it. So divided by 100, the decimal's here, right? Move it over 2 places. So your final answer would be 73.26. All right. 3.1 times 1,000. That means we're moving the decimal over 3 places to make it bigger this way. So I make 3 little jumps. So my final answer is 3,100. All right. I think we'll quit there and you can do whatever's left on your own. Don't forget this is 911 times 911. All right. All right, I'll start the next lesson now.